Hello and welcome to a new Voltlog. As you can see, I have the obligatory Christmas hat on my head. This is a part of the decor these days, but I will take it off later. This is just an update video to let you know how things are going with my CR-10 3D printer. As you may know, I've mentioned this before. This is my first 3D printer and the first 3D printer I play with. I haven't touched the 3D printing field before, so I'm presenting you my experience through the eyes of someone who doesn't know anything about these things. Also, please excuse the mattress in the background. This was part of the this room as I rented the apartment, so there is nothing I can do about that. And I think it also helps a little bit with the soundproofing of the room. So I got my CR-10 3D printer from banggood.com. I got it for $370. It was on sale on Black Friday. I had a coupon, so I got it for $370 with shipping included. I'm not sure if it's the best price. Maybe you can find better prices somewhere else, but I don't really feel confident purchasing expensive stuff from a place that I do not trust. In any case, there will be links to this product on Banggood in the description below, so check them out if you are interested. It took about 3 weeks for the printer to arrive in Romania, which was faster than I was expecting. Other packages from the same period take 2 months to arrive, but this one just 3 weeks, so I was surprised to get it that fast. It was a rather big box, and inside the printer was almost completely assembled. There were basically 3 main parts inside the box. It was this base section, which contains the moving printing bed. Then it also had in one piece this vertical section with the z-axis, the x-axis, and the print head. And the third main piece was this control unit. It was pretty easy. I only had to install some screws through the bottom to hold this top piece. I had to do the wiring, but every wire is clearly marked, so it was pretty easy to connect to the right spot. I think I had to insert this Bowden tube. That was pretty easy to do, so nothing too difficult. Everything was very easy to assemble. There are plenty of instruction videos on YouTube that tell you how to assemble and tune your CR-10 for the first print. Mostly it's 10 minutes of video explaining everything you need to do. If you're wondering, this is an IKEA desk. It is probably one of the smallest and the cheapest IKEA desks that you can find. I got it for $20 from a guy who had a bunch of these new old stock, so I'm pretty happy with how everything works. The printer just fits on this desk. There isn't much room around it, but it's enough, and I don't want to crowd my lab with a very big desk. If you have the space and you can afford it, by all means get a bigger desk. It will be more stable than this one. A heavier desk will be better for a 3D printer which has all of these moving parts, but for me it's good enough, and it does the job just fine. So as you can see, I got rid of the hat so we can continue with the 3D printer. Let me tell you a few of the things that I did after assembling the 3D printer. So the first thing I remember doing was tightening the bottom wheels, the ones for the y-axis, the ones where the bed moves. There are, I believe, 6 wheels in total, so I tightened those to get just this tight system with no wobbling in there. It's important to do that to get some good printing. I also checked all the other wheels in the system on the x-axis, on the z-axis, and tightened those as well where necessary. You don't want to over tighten them, because then the axis will move with difficulty, so that might be a problem as well. I checked all the other screws on the frame and make sure those are tight, so the frame is holding together nicely and firm. Next thing I did was to tighten the two belts. That's pretty easy to do. You have this y-axis belt and this x-axis belt. It's pretty easy to tighten those, and you will most likely need to do that because during shipping they are not very tight. I think they leave them a bit loose from the factory, so nothing happens during shipping. The next thing I noticed was a problem with the Z-axis screw, which was not coupled to the motor. After asking a few questions on a Facebook group, users have reported that they are shipping the CR10s like that with the Z-axis motor decoupled, so it doesn't get damaged during shipping. So I'm not sure if that's true or not, but if you find yourself in that situation, you will need to attach your Z-axis lead screw to the motor with the provided coupler. In my case, it was a problem because the lead screw was not aligned with the motor coupler. It was a few millimeters off, and I couldn't just couple those two without bending the lead screw. And bending the lead screw is not a good idea. It will most likely cause it to get jammed, and you don't want to do that. So what I had to do is loosen the motor mount, then loosen these two screws just to be able to adjust the Z-axis lead screw to make it fit in the coupler on the motor. So I attached the lead screw to the coupler, and then I retightened all of those screws to complete the system. You want to tighten these two screws until you feel some tension and the Z-axis lead screw is not wobbling around. You don't want to over tighten these two because that will cause too much friction in the Z-axis. You want to get them just right to allow you free movement up and down all the way to the end stops on the Z-axis. The next thing to do was to remove the plastic wrapping from the print bed. That was for protection during shipping. So after removing that, I moved on to adjusting the leveling of the bed. And to do that, you have 4 of these screws on the bottom that you need to adjust. These are spring-loaded screws, and they control the height of the bed in all 4 corners. I did as instructed. I lowered the print head very close to the bed, and then with a sheet of paper I adjusted all 4 corners until I felt a little bit of tension in the paper between the print head and the print bed. It was okay, but after doing all 4 corners, I noticed that in the middle I still had a different spacing when compared to the corners. And I think there's nothing I can do about that. It's just how the print bed is built. It's not level all around. One improvement I might print next are some bigger adjustment knobs instead of these small ones, because it's quite difficult to get your hand under the bed in these positions and adjust it. With some bigger wheels, I could just simply adjust it from the exterior of the bed, and that should be better. There is also a slight imperfection I noticed with my printer on the y-axis. Like when I move the y-axis, I can feel a slight bump at some point, and I'm not sure how that will affect my my prints, but it's most likely caused by the wheels on the bottom. That should be a relatively easy fix later on. If I would like to upgrade those wheels, I can find a set of those wheels and I can just replace all of them. That should give me a smoother motion on the y-axis. So far I haven't noticed any problems with that, so I will leave that for later. Next, it was time for my first print, and I almost damaged the SD card slot because you are supposed to insert it upside down, and I didn't know that. This was shocking to me Why would anyone do something like that on a product that is supposed to be used by people all around the world with very little instructions? Because let's face it, the instructions you get with the printer are not very nice or usable. So when I saw I'm unable to insert the SD card, I searched the internet and found out that you're supposed to insert it the other way around. So I thought I broke my SD card slot, but it turned out it survived. So just for your information, you're supposed to insert the SD card upside down. I have also ordered one of those SD card extender cables, so I don't wear out the SD card slot on the printer itself, and it's easier to work with one of those extender cables. Also, the noise the machine makes when it's working, it's pretty loud. It comes from the fan that it uses. I think it has 3 fans, at least 3 fans. There are 2 on the print head and 1 on the control unit, and they are very loud. I've taken a recording with my sound measuring tool, so as you can see, it's a pretty loud unit. Most of the noise comes from this front fan. This is the loudest out of the 3, and this is important because it cools the print head. So I need to make sure I get a silent replacement fan, but with a similar airflow as this one. And if this is a Chinese fan with no datasheet at all, it's going to be hard to know the airflow of this fan. For the first print, I went with just a file I found on the supplied SD card. By the way, the printer comes with a card reader and an SD card. I believe it's just a 1 gig SD card, a very cheap SD card, but it does have the instructions and some files on the SD card that you can print. So I went with that file I found on the SD card. I had print, the settings were 55 degrees for the bed temperature, and after a few runs of the head on the print bed, the layers started peeling off immediately. I didn't use any tape on the print bed. I didn't use any hairspray to help with the adhesion, but the problem was not the print bed. The problem was the bed leveling. I needed to lower the distance between the print head and the bed, so I did exactly that. I readjusted the bed leveling to lower the distance, and for my second print, with exactly the same settings, which were the default settings for that file I found on the SD card, it printed this baby demon without any issues. I mean, it literally looks flawless, with no defects I could see whatsoever. I mean, with my level of expertise, which is basically 0 when it comes to 3D printers, this print looks perfect to my eye. So I consider this to be a success, and that's something to note. That's something pretty important about this 3D printer. It's one of the few printers that you can get set up and working very fast. And there is one important step that I skipped with my printer, but I recommend you do not skip with yours if you get a 3D printer, and that is to open the control box and check the wiring inside. There are many reports on the internet of people finding out that there are wires inside touching the fan, and that's not good at all. It will make noise at first, and then it could cause some electrical fault. And most importantly, on the power supply inside the control box, people have found that on the terminal block of the power supply, the screws were not tight enough, and that is a serious fire risk, because there is a decent amount of current flowing through those wires, and if the screws are not tight enough, you might get a fire started from that terminal block of the power supply. And there are reports on the internet, and people are showing like burnt out control boxes complete with the table, and they barely saved the house from a serious from burning down. So that's a serious issue. I highly encourage you to open your control box and just check the wiring inside. Make sure everything is tight and there is no risk of short circuit, or there aren't any loose connections. After seeing how easy it was for me, a real beginner with 3D printers, to get it up and running and with some pretty good results in printing, I can honestly say this is the go-to printer for beginners. I already knew this when I purchased the printer. There were a bunch of good reviews of this printer, and they all said the same thing. It's print out of the box with this printer. Well, it's not exactly out of the box. You need to do a few adjustments on the printer before you get it ready for your first print, but that's like a few hours from getting it out of the box, so I don't see that as a problem. It was pretty easy for me to do all of those adjustments, and I'm getting very good results with this printer. There are a few upgrades I would like to do to this printer, and the first one is the auto bed leveling sensor. It's kind of a capacitive sensor which can sense the bed, and I have already ordered that sensor. It's used heavily in the industry, so they're pretty cheap on eBay. Of course, they're made in China. They're one hung low. You don't get any of the Omron sensors because those are hundreds of dollars. But you can get one of these cheap sensors for a couple of dollars from eBay, and you have to print a bracket to mount it on the print head, and then upgrade the firmware in the printer to support that sensor. And what the printer will do is scan the bed and create a digital map of the height of your print bed, and then it will use that map whenever you print something, and it will take into account the various offsets on the print bed so that you get a perfectly level print. And then you don't have to mess around with these adjustment wheels because the printer will always have that map in its memory. So that's a pretty nice upgrade to do. It's pretty easy to do, pretty cheap. You don't have to invest a lot. So that is the first upgrade I'm going to do to this printer. The next upgrade I would like to do is, like mentioned before, changing the fans with some which are silent, because like I shown, it's pretty noisy to run this 3D printer. It pretty much disturbs me when I try to work in the same room as the 3D printer, and that's not okay because some of the prints might take several hours to finish, so that's not a very good thing. What I need to do is find silent fans which have a similar airflow to the stock fans on the 3D printer, and then I will do this upgrade. Another upgrade I would like to do is change the extruder. Or there are two options here. I can either change the extruder or print just an adjustment part, because one of the problems I'm having is the filament is touching the Z-axis screw, and I'm really not sure how they missed this in production. It's pretty obvious that it's a flaw in design and should be corrected in some way, because having the filament touching the Z-axis screw could influence the printing in several ways. So I could either change the extruder altogether and get a better extruder, or I could just print a small part that could divert the filament away from the Z-axis screw. And there are many other upgrades available for this printer, but right now I don't feel the need for those because I'm mostly printing low resolution parts that do not need the high precision that other people are looking for with this printer. For example, I printed these stabilizing fins for my flying wing. These are pretty simple parts. You don't need anything special to get something like this done on the CR-10. It just works out of the box. The slicing software that I'll be using is Cura. I like the interface. It was pretty easy for me to learn how to use it, so I'll keep using it. I'm not sure how the previous versions were, but the latest version is just so easy to work with, and it already has a profile for the CR-10 3D printer, so it's as easy as installing it and starting using it. I haven't designed any 3D parts yet, so I'm not sure on what kind of CAD software to use, so I'm open to suggestions. Please let me know in the comment sections below what software you're using to design your 3D parts. I need to find something that is both easy to use and provides me with enough flexibility to design the parts that I need. So for the end note, let me get my Christmas hat on. So in the end, I wish you a Merry Christmas and a Happy New Year. May all the good things happen to you. And I hope to have you as a subscriber in 2018 as well. Thank you for watching, and I'll see you next time.